Hello, I am Peyton Bezon.
And I'm Jacob Hackbarth.
We are representing vehicle number 24 for North Competition, vehicle number 4 for South Competition, and we are hailing from the Missouri University of S&T. We have worked very hard on this vehicle this year, incorporating and testing many safety features to protect our riders and other competitors during competition, as well as performance characteristics to try to make this vehicle the best that we could possibly take to competition this year. Some of the safety features we have incorporated, many required by ASME HPVC, such as the encompassing roll bar, the 4-point harness, unobstructed vision, as well as some features that we have deemed necessary for safety, such as disc brakes to decrease our stopping distance. The performance characteristics of this bike, it has a turning radius of 19 feet 4 inches, as well as a stopping distance of 175 inches from 17 miles an hour. Speaking from experience as a rider, this vehicle is stable from 1 to 38 miles an hour.
So we did a lot of testing this year, which included roll bar testing. And in this testing, we were originally hoping to use the Civil Department's compression testing equipment. However, in light of recent events, we did not have that opportunity, and we had to use what we had available in our apartments and houses. And what we found is we used a heavy-duty scale and a heavy-duty ratchet strap, which we were able to apply a force of 890 pounds in a top-load scenario. And in that, we had a deflection of 0.21 inches, well within the specifications that we needed to be. And we also tested side loading, in which we applied a 607-pound force from the side, and we had a deflection of 3/8 of an inch.
One of the largest pieces of testing we were able to complete this year was trailer testing, in which we set up a course of 0.68 miles, or 1.1 kilometers, to try to mimic the length of the North Competition course. In this, our riders would maintain a 200-watt average power. For our unloaded bike, we saw times of 2:35 and 2:26 minutes for each of our riders. From a 50% loaded trailer, we saw times of 2:57 for both of our riders. This is maintaining the same 200-watt power to try to keep this consistent. For our fully loaded trailer, we saw times of 3 minutes 7 seconds and 3 minutes 2 seconds, once again trying to maintain the same 200-watt power. We didn't want that to change during competition. So as you can see here, for our unloaded bike, our lap time was 2 minutes 30 seconds. For our half-loaded trailer was 2:57, and we had a lap time of 3 minutes 4 seconds for our fully loaded trailer. So, taking this into account, we have added 1 minute to our total lap times for our towing portions to account for attaching and detaching the trailer during competition. Following the formula for the trailer pull event as laid out by ASME, the 50% loaded trailer would receive 1 extra lap, and the fully loaded trailer would receive 2 extra laps for each lap completed. The time to complete the equivalent amount of laps, both 2 and 3 laps, for the unloaded bike was determined as 5 minutes for the 50% loaded trailer and 7.5 minutes for the 100% loaded trailer. Since our equivalent unloaded times have exceeded the towing times, we have decided that it would have been advantageous for us to compete in the trailer pull event this year.
Another type of testing we did was the drivetrain testing. We wanted to find out what our power losses were from the crank into the rear wheel. We were able to use a power meter inside of the crank and a hub-style power meter for the rear tire, which eliminated the possibility of the tire slipping and giving us false results. In this, we found a 3 to 5% loss throughout the drivetrain, which at 308 watts came out to be about 10.9 watts worth of loss. We intended to do some more testing with different variables that we could control. The shape of the sprockets between the interchanges, the amount of tension that we put inside of each chain, the type of lubricant we used on the chain, and the geometry of how the chain gets from the front to the rear.
So on behalf of all of Missouri S&T Human Powered Vehicle Team, we would like to thank you for your time and consideration.